In this video, we're going to identify simple events and sample spaces of probability of experiments from 3.1. Let's identify the sample space of the probability experiment and determine the number of outcomes in the sample space of the event given here, randomly choosing a number from the odd numbers between 1 and 9 inclusive. So all of the odd numbers between 1 and 9 inclusive will be my sample space. It'll be 1, 3, 5, 7, and 9. And there are 1, 2, 3, 4, 5 possible outcomes there in the sample space. Similarly here, we're going to be playing the game of roulette, where the rule consists of slots numbered 0, 0, 0, and then 1 through 34. So there are 36 possible slots or outcomes there. And the sample space is 0, 0, 0, 1, 2, the way up through 34, which is A. All those possible outcomes are our sample space. When we toss two coins, one after another, possibilities being heads or tails for each coin, we can have heads, 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 tails, tails, heads, or tails, tails as our outcomes. There are 4 possible outcomes, and the correct tree diagram for that would be that we could have heads or tails for our first one, and then heads or tails for our second one. So that's D, where we can get heads, 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 tails, tails, heads, tails, tails. That's where we get that from. It's a tree diagram that looks like D. All right, identify the sample space and the total number of outcomes. Rolling 2 6-sided dice, one after another. So we can have 1, 1 through 1, 6, 2, 1 through 2, 6, all the way up to 6, 1 through 6, 6. So that's D there. There are going to be 6 times 6 is 36 possible outcomes. We're assuming that these dice are able to be distinguished from one another, and that we can tell the difference between a 1 and a 2 and a 2 and a 1. If not, if the dice are identical, then there's actually half as many outcomes that we can see, where we would just see a 1 and a 2, but we wouldn't care about which order we saw them in. More about that later, but let's assume that this is like a red die and a green die, where we can tell the difference between them. All right, so that's going to look like B here, where we can roll any value 1 through 6 on the first die, and then any value 1 through 6 on the second die, and 6 times 6 is going to be 36. That's it for this video. We'll come back next time and talk more about 3.1. See you for the next video.